Hello, everyone. My name is Aljoscha Köcher. I'm a researcher at Helmut Schmidt University in Hamburg, Germany. And together with my colleague Tom Jeliniewski and Professor Alexander Fay, I developed PLC2Skill, which is a method to automatically generate semantic skill models in the form of an ontology from existing PLC code. And in this video, I'm going to show you how our method works on a little demonstrator in our laboratory. So you can see the demonstrator right here. It's a little processing station consisting of two modules. There's a drilling module on the left side and a handling module on the right side, and they both have separate PLCs. So each module has its own PLC. And on the screen in the background, you can see our skill-based manufacturing execution system. Okay, so let's look at our PLC project first. It's actually quite a simple, basic PLC project. We have two different controllers, which you can see here. This is the drilling controller, and there is another PLC for the handling module. And if you look inside one controller, in case of the drilling, you can see here that the main task of the PLC calls a skills program, and this skills program basically just calls our two skills. In this case, a drilling skill and a punching skill. And if you look here, you can see that there is a function block and a sequence in a sequential function chart for each skill. So, for example, our skill function block, or our drilling skill function block, which is a concrete implementation for our drilling skill, it extends the basic skill function block of our PLC2Skill library. And it uses some other function blocks and structs of the library. You can see here that we defined an input, which is a skill parameter, and will later be published as a skill parameter and can be used by a manufacturing execution system. And we defined an output as well. This one can be kind of read and monitored by the manufacturing execution system. And we implemented two methods in this case, just to kind of close the normal manufacturing loop, so to say, of the state machine. We implemented an execute method in which we just send a start command to the actual drilling sequence. And as soon as the drilling sequence completes, we can complete the execute state so that we can then issue a resetting command or reset command and go through a resetting step. The drilling sequence is just the basic process, the drilling process, which is implemented here. And this is what gets called by our skill. So the skill is kind of the interface which gets invoked by the manufacturing execution system and then kind of interacts with the actual drilling sequence and passes the input parameters to the drilling sequence and controls the drilling sequence. After programming this PLC program, we can just export this project to PLCopen XML or as a PLCopen XML file. And in this case, I'm just going to export these two here separately so that we can later map them separately into our skill ontology. So I would just select this drilling application and export it to PLCopen XML, which in this case I already did, so I'm not going to do that again. Okay, we now want to execute our drilling and handling skill. And as you can see, there are currently no skills registered in our manufacturing execution system. And we can now register a skill. We could do that by just uploading a turtle file, so an ontology, but we are doing it via a mapping right now. This is what I want to show you. And I select PLCopen XML file. In this case, it's the drilling file, which I just showed you how to export in the beginning. And I have to provide some additional information like the IP address of the PLC and the root component of all the node IDs of the OPC UA server. These two information are unfortunately not preserved in the PLCopen XML file. Yeah, we can see that a skill has been added and its initial state has been picked up. Actually, two skills have, of course, been added: the drilling skill and the punching skill. And you can see the parameters of the skill, and you can see the output that each skill has. You can see the transitions that can be fired. And I'm here just going to set the number of holes to be 4. And I'm going to start the skill. And as you can see, the drilling process starts. The part gets drilled 4 times. And as soon as the skill completes, you can also see the state change. The current state is now complete. Good, so now that the part has been drilled, I want to use the handling module as well. I want to use a skill of the handling module to transport the part to one of these 2 slides on the right side. And in order to do that, I have to register the skills of the handling module. And I kind of repeat the same steps that I used for the drilling module here. I select the PLCopen file of the handling application. I insert the IP address of the handling module and the beginning of the node IDs. And as soon as I submit, the mapping gets executed and new skills are added and their initial state gets picked up. You can now see that there are 3 additional skills. There is an ejecting skill to put parts on one of these 2 slides. There's a loading skill to bring new parts to the drilling station, and an unloading skill to remove parts from the station. And I'm now just going to use the ejecting skill. I set the ramp to number 2, which is the right ramp, and I'm going to start the skill. And you can see the gripper instantly starts and the actuator moves the part, drops it on the slide, and as soon as the skill completes, you can see the current state changing to complete. So that's it for our little demonstration of PLC2Skill. We published all source code on GitHub, so you can find the mapping application, the mapping rules, and the PLC library on GitHub. If you have any questions, you can find me on LinkedIn and ResearchGate. Yeah, please feel free to contact me. You can also check out our institute's website. And of course, you can also comment on this video. So thank you and bye-bye.